Hello everyone and welcome to Network Playroom. In this video we're going to do a GNS3 lab and we're going to focus on the ebgp-multihop command and form a multihop eBGP relationship between R1 and R3 in the topology you see on the screen here. This is basically the same topology that I've used in my previous GNS3 lab video where we configured eBGP neighbor relationships between R1 and R2 in different ways, using the directly connected interfaces and also the loopback interfaces. I showed a couple of different ways of configuring that and what you need to consider and what configuration is required to enable those eBGP relationships to come up. But we left out the actual multi-hop eBGP relationships, which is why I'm doing this video today. So let's play, let's get right to it. And actually, before I jump on the device console here, let me just give you a little background of what is already configured. So I have enabled EIGRP routing between all of these routers just to make it easy to advertise all those networks. Obviously, this is not a realistic scenario. You would not see this kind of configuration in ISP environments. As shown on the diagram here, all these routers are in different autonomous systems. And again, it's a very weird design, but it's going to work for our purposes. And there's not going to be any tricks this time. In my last video, I had configured reachability between R1 and R2 using default routes, which is why the PGP session did not come up, because that is not allowed. And one more thing, I have actually recorded this video before, but I made a hilarious mistake and I got completely sidetracked and confused myself, and I thought it would be a good lesson for you to learn. So I'm going to demonstrate that right now. And for that purpose, I have a packet capture enabled on this link right here. You can see this little magnifying glass icon here. So we're going to look at some packet captures. So let me just demonstrate what I have done in my last failed recording. So let's just enable a normal eBGP neighbor relationship between R1 and R2 before we configure a PGP session between R1 and R3. So I've basically removed all PGP configuration. What we have so far is only the AS number, essentially. So you can see there's nothing else right now, and we can verify connectivity to R3 by pinging it and sourcing it from the loopback 0 address. So let's just configure an eBGP session between R1 and R2. So let me just start it right here, router PGP 65001, and then let's use the directly connected interface, so 192.168.12.2 and remote AS 65002. Let me actually pause the recording here for a second. I want to verify something on the Wireshark. Okay, now when I hit enter, we should see R1 start the process to establish the PGP session. So let's do that right now. And now let's go to that packet capture. I have it open here on my other desktop. So this is what I had done. I had applied a filter using the PGP protocol, but we're not seeing any packet captures, right? Why is that? Can you think of the problem? Pause the recording for a moment and think about why we're not seeing any packet captures right now. So why didn't it work? Let me explain. Notice that I've applied the filter PGP. How does PGP operate? Well, first, it actually establishes a TCP session before the PGP packets are exchanged. So my filter is wrong. Right now, the TCP session is not established because the other side is not configured. So what I should have applied is actually a TCP port filter. And now we can see a lot of packets. So you can see here that R1 is trying to, actually well, it doesn't really matter which packet we look at, but because R1 is doing it repeatedly. So here, for example, it's being sourced from R1's fast Ethernet 0/0 interface with this IP address, going to this destination address, which is what we configured in the neighbor command. It's a TCP packet, and notice here it's going from this random source port number to TCP port 179, which is the port that PGP uses. And then, of course, there's no reply from R2. There's no SYN-ACK. The TCP session is not established. So it's reset and the PGP or the TCP session doesn't form. So that was my little mistake right there. We can configure the other side as well. So we can see the remaining part of the session establishment. So router PGP 65002, neighbor 192.168.12.1, remote AS 65001. So we should see the PGP session come up. And there it is. So let's go back to the packet capture. Let's see. And notice here, now we're seeing the PGP packets as well. So right here is the PGP open message. This is where we start to see those PGP packets, which is why my filter didn't work before. So now actually, if we filter it using PGP, we're gonna see these packet captures right now. So there's these open messages, keep alives, and update messages. There shouldn't really be anything in the update messages right now because we haven't advertised anything. Okay, now while we're in this packet capture, let's actually look at a couple of things here, which we're gonna need when we configure the Multihop eBGP session. So this is already highlighted. This is actually what we want to look at specifically, the time to live value. I've repeated this so many times that the default TTL value for eBGP is 1, and we're gonna change that when we configure the Multihop eBGP session between R1 and R3. So yeah, let's just keep that in mind. We'll leave this packet capture running, but we'll return to the device console now. So we're really not gonna need to do any more configuration on R2, so let me jump back to R1. So we have already discussed the theory about multi-hop eBGP neighbor relationships and the eBGP multi-hop command in my previous video, but let's just do a quick recap of what it actually does, or some things that we need to remember about eBGP neighbor relationships. So again, as we just looked at, the TTL value is 1. So that is something that we need to modify for the packets to reach R3. Because right now the problem is, if I configure eBGP session between R1 and R2, the packet will get to R2 and the TTL will go down to 0 and the packet will be discarded. So they will not even reach R3. And if you remember with the previous videos, some other things to remember about eBGP neighbor relationships are the directly connected check. So by default, when you configure an eBGP session, the Cisco router checks if that neighbor address is directly connected, and if it's not going to even bother trying to establish that session. So when we configured an eBGP session between R1 and R2 in my previous video using the loopback interfaces, we got around that directly connected check by disabling it using the disable connected check command. But that's not going to work in this case either, because we still have that TTL issue. And then one more thing to consider again is the source IP address. So if we're using these physical interfaces, the fast Ethernet 0/0 interface and fast Ethernet 0/1 interface in case of R3, it's not going to be a problem because these are going to be the exit interfaces and the IP address is taken from there. But if we use the loopback interfaces, we need to change the source IP address, and that is done with the update source command. I can actually show it to you both ways. We have a small lab, so it's not that much trouble to configure R1 and R3 using the physical interfaces and also using the loopback interfaces. And now let me bring up Peter's amazing post about the ebgp-multihop command so you understand what it does. So I have it open here. So when we apply the ebgp-multihop command, it essentially does two things. First of all, it implies this command, the disable connected check, and then it actually changes the TTL value. So this is why we don't need to separately use this command if we're using ebgp-multihop. And we're going to specify a value. If you leave it without any value, then 255 will be applied automatically. I can actually show it both ways if I'm gonna configure the ebgp-multihop neighbor relationship using both the physical interfaces and the loopback interfaces. All right, let's go finally after that long explanation. All right, so we're on R1. So let's configure neighbor 192.168.23.3 and remote AS 65,003. And now we're gonna need the ebgp-multihop command. ebgp-multihop. And let's just do a random number. I like 7, so let's go with that. Obviously we don't need a TTL value of 7 because we're only essentially one hop away, but just to demonstrate this. And now let's actually go to the packet capture to see if we can see the new TTL value. So let's scroll down a little bit. Right here. There we go. So you see that the TTL value has now changed. All right, let's go back to the lab here and let's jump to R3. So now router PGP 65,003 and neighbor 192.168 12.1 remote AS 65,001 neighbor multi eBGP Multihop 5, for example. And there we go, the PGP neighbor relationship is up. So another way that we can verify that TTL value is from the show PGP neighbors. And I didn't type it correctly. Here we go. All right, so let's find that part right here. Or I should say the last part on this line. Outgoing TTL is 5. And on R1, I configured it as 7. So show IPPGP neighbors. Remember, we have 2 PGP sessions configured on R1. I was like, how is that still 1? So I should have specified the neighbor. It would have made it a little bit easier here. So I should have really done it this way to remove the part of R2's PGP session. Yeah, again, right here. Outgoing TTL 7. So I show IPPGP. I mean show IPPGP summary. So here we can see those 2 sessions configured on R1. So this is just when I demonstrated that I made a mistake in the packet capture in my previous recording, and this is the new one we've just configured, the true eBGP multi-hop neighbor relationship with R3. So now let me do the same thing using the loopback interfaces, just so I can show you the eBGP multi-hop command without applying any specific value. So let's go back to the router configuration mode, 65,001. Then let's do neighbor 3333 remote AS 65,003. And now remember, we need to change the source IP address, and we can do that with the update source command. And then again, we need to apply the eBGP multi-hop command, but now let's do it without a value. All right, and let's actually go back to the packet capture again. Let's see what we have here. Okay, this one, for example. There we go. So time to live is 255 now. So you can see the packet is sourced from that loopback interface on R1, going to R3's loopback 0 interface. This is TCP going from this random port number to 179. And you saw that I did not configure the eBGP multi-hop command with any value, so by default it's set to 255. So let's go to R3 and configure it on that side as well. Router PGP 65,003 neighbor 1.1.1.1 and remote AS. I can't type today. Okay, neighbor. There we go. And neighbor 1111. No, come on. Okay, update source. And then neighbor. And that's it. We should have another eBGP session between R1 and R3. Again, this is not a realistic scenario. I'm just showing you the operation of the protocol and the use of these different commands in this GNS3 lab. And now again, if we look at the show IP-BGP summary command, we can see those 2 sessions on R3 right now. And we can also look at the show IP-BGP neighbors. And 1.1.1.1. And let's find that line again right here. Outgoing TTL is 255. So that's always good. Our command output matches what we saw in the packet capture. So basically that's it for this video. Let me know in the comments if you figured out why we didn't see any packets in Wireshark when I had applied that PGP filter. Hope you guys enjoyed the video. Thank you for watching, and I'll see you next time.